Welcome, Gayatri and Chandu. I hope you guys are doing great. And we have a lot of people today attending the workshop over Zoom, over YouTube. And so just to quickly introduce the panel of industry experts that I have today with me. One is Gayatri and second is Chandu Satish. And just to give a quick round of introduction on both these fine industry experts. Gayatri brings in 17 years of data engineering experience in this table. She has worked with large companies, large global companies as well, large retailers, one of the world's largest retailer. She has worked with a lot of consulting firms as well, some of the big five, tech consulting firms as well. And she has been a true expert. She has experienced all different kinds of phases in the data pipeline, the data engineering pipeline. And Gayatri, welcome to the discussion. Thank you, Prateek. And I also have Chandu Satish. He has around 7 years experience in the data engineering world, very hands-on guy, expert in Apache Spark, expert in Hive, expert in Spark SQL and AWS from a cloud data engineering perspective. He has also worked with global consulting firms, and he has over his experience, he has somehow specialized in healthcare. Okay, so very deep into healthcare consulting as well, but from a data engineering perspective. So Chandu, thanks a lot for accepting this invitation. And I hope you guys are, both of you guys are doing great. Yeah. And guys who are attending
this thank you so much for your kind words. Yeah.
Thank you. And guys who are attending the session, just to put it in the right perspective, guys, you can ask any questions. We are monitoring the questions asked in YouTube as well, and I'll be more than happy to answer those questions, whatever question that you have. I'm monitoring those questions as well, and feel free to type in your question on the YouTube channel, and I'll be the conduit through which we will ask these industry guys the questions. So just to set the expectation, just to set the context, guys, the topic of discussion today is why is data engineering a recession-proof career, specifically in this particular year that we're talking about, 2023. Why there are several prospects available in the data engineering world. So a couple of industry reports that we're just going through, before coming to this panel discussion. So what I found is $77 billion industry is what data engineering is going to become in 2023 alone. And which is, just to put it in perspective, which is almost 70% of Bill Gates' net worth and almost 60% of India's overall IT export to the world. So it's going to become a huge industry in itself. $77 billion means a lot of, lot of prospects available in the data engineering world in the world. 60%, one of the other reports that I was looking at, that 60% of the companies are using some of the other things in data engineering. Okay. However, what was surprising to know as the statistics was that only 14% of these companies who are using data engineering pipeline have access to the true data engineering pipeline data. That means there is still a big adoption of data engineering practices, even though the companies have started investing into technology to help them manage the data pipeline. But there is a huge gap between what employees of these companies know about using this data engineering entire pipeline, and that is where the entire context of this workshop is, that it still has a lot of opportunities for people who understand the data engineering pipeline to make a career. So with this note, I want to start with my first question to Gayatri and then to Chandu, the same question. But the question is that in your in your experience, in your analysis, what do you think? What is data engineering and how is it different from data science and data analytics? A lot of people, a lot of audience ask us this question. What is data engineering and how is it different from data science and data analytics? So if you can shed some light, Gayatri, on it.
Yeah, sure, Prateek. Yeah. So before jumping into data engineering, so let me start what data is. So before a decade back, right, the data was not so much. Now everything is a data. See, before if we have to go out, like we used to call some cab drivers, some numbers, and we used to go. Now it is Uber, where we know like where the cab driver is, we pick it up. If you want any food delivery, we just order it and it comes over there. So everything has become more digitalized, even
Right.
our phones everywhere. So the volume of amount of data what generated now, it's been tremendous.
Right.
So like previously, so there was tremendous. So we need to have a better way to organize it. So previously, like before the decade around, the volume of data, if you see the organizations where I work, it used to be in like a few terabytes of data, like 50 terabytes around data was what was there throughout the organization, which they need to analyze it and make the decision. But now it is like petabyte, hexabytes of data is getting generated. Even because now that it's been digitalized, the world has been digitalized so much, even the organization is unable to know what exactly I'm going to use with this data. Even it's like hardly like some amount of data, 5 to 10% of data is what they're really using it for their analysis. That's
Right.
all. It's like lying in different places. They don't know where the data is and what to do with the data. So that is like the current trend, what I see in the industry. So for data engineer job, what is going to be is like, how are we going to organize this data in simple terms? Because the data has been scattered everywhere we get the data, it's been scattered around. It has to be in a simple form so that the data analyst or data science, which I'll talk about later, like they need to get the right data for it. So
Right.
in a simple term can be like, previously there was internet and we had many websites, we had many information sites over there. But
Right.
without having a proper search engine like Google, we are not able to get that information. We need to remember the site name to get the information. Having a Google search engine sort of it, which has really made our life simple to analyze or get the data anywhere. So data engineering role is something like that. They need to build some search engine such a way, like whoever wants the data, what they need, they can get the data.
In
So
an organization, in an
in an
enterprise.
organization, yes, yeah.
Right.
So
Okay.
that is what the data engineer role is going to be on the simple term. So, and how it's that is going to be different from a data analyst or a data science. So data analyst are the person. So basically for a data engineers, right, there is not necessarily to understand the complete data. They need to know how they need to organize the data or what is the domain they're going to work on it. They really don't need to know each and every data of it. They need to put it in the right way and they can consume it. Where in case of data analyst or a data scientist, they need to know the data, the complete data, what they're going to read. They need to know each and every data so that they can make an analysis out of it. They can, data analysts are the ones who generally analyze the data and creates the trend, some reports, and that can be used by their management for the decision making. They might be telling there is we can see there is a sale drop gradually, what we see it in last few weeks or months or something. They need to act upon immediately, or they might say some suggestion like, can we put some offer like this so that the sale is going to be. That's what the data analyst is going to give us. So they're going to create a report out of it, and the decision, like the management is going to make a decision. What decision are they going to make about it? But whereas data science is like, there is like little bit of overlap, but data science work is like completely like little bit different. So they leverage most of machine learning algorithm, where they build a model, machine learning models out of the data, and they predict it, not just they predict it, they identify the trends. Not just the trends, they identify, predict what's going to be in the future, what is the, what could be the forecast, and what is going to be like, if there are any anomalies over there, like what has caused it. They might build some machine learning model and they can identify. We see a drastic sales down because the server in some point of time of ordering, it's going down. So that's why we see a drastic loss. The machine learning will be able to identify it, whereas the data analyst will not be able to identify it. So that's where the difference of a data analyst and the data science is going to be.
Okay, very good. So a couple of points from you, what you said. One is very nice. I like that fact that you mentioned that data engineers are the Google of enterprise data within a large organization. That means one of the main roles of a data engineer is to make sure that the data is available to all the people who are going to use the data in in a convenient place, right?
Yeah.
I think that is a core role of a data engineer. And then second, you said the difference between a data science data engineer and a data analyst is that data analyst work on past data and they try to try to identify trends and analyze and create reports. Data scientists have some overlap with the data engineers as well, and have a lot of overlaps with the data analyst as well. But data scientists are also closer to data analysts, whereby they also analyze past data and then they predict what could happen in the future as well.
Right.
They apply a lot of machine learning algorithms as well. But data analysts and data science guys are guys who are going into the data and trying to make sense and try to relate it to solve business questions, whereas the data engineers are the people who are just making sure that the data infrastructure is available so that any data users can consume the data.
Yes.
Very nice.
Yeah.
Thank you. Follow-up question for Chandu there. So Chandu, in your experience, right, what are the things that a data engineer do on a daily basis? I mean, what is it that you would do, when you go to the office when you were a young data engineer from morning to evening?
Yeah. So basically, our day-to-day task for a data engineer involves around basically doing the ETL work. So we know there is some data, some terabytes of data is there. So there is one particular word that Gayatri mentioned. Data is scattered around a company. So if you take a organization where they have a couple of thousands of employees, so all the teams, all the Scrum teams that are going on, it's going to be like 10 people will be there. So we are developing a project, and so we don't know. I mean, so we have loaded some data. So the same data, whatever we have loaded, and whatever data that we are giving it to the reporting teams and all the Tableau dashboards. So it doesn't make sense to all the users. So they're going to keep it and they're going to use it. But so there's a larger picture here. If you see the same data, whatever we have loaded, the same data can be used across the organization, right? So basically data engineering revolves around data loading. So we need to, so the point where the data lands in the environment, and the point of time where we send it to all different teams. So we send it to data science team, we send it to the data analysts. So they're going to, I mean, so let's take data analysts. So they are going to be the bridge between the business users and the developers. So
Right.
they are going to make models on top of it, data models, and they are going to make more sense of the data that we are receiving. So from data engineering, so once we receive data, we need to cleanse that data, because so all the data that we are collecting through mobiles, the centers, I mean, so the IVR centers. So all the centers that collect this data, it's all unstructured or semi-structured, maybe like 5 to 10% is structured. So
Right.
far, all the data engineering is revolving around structured data only. But there are tons of data, like 95% of the data is unstructured. So there is a large possibility of analyzing this unstructured data. So basically data engineering, we get the data, cleanse it, and so whatever the requirement is there, depending on that, we do a lot of transformations on top of it. So get data from there, get data from here. So we are going to get all the data, and we are going to give the same input to our reporting team, so where they are going to create a Power BI or Tableau dashboards. And so it doesn't matter so if the data is in the rows and columns format, right? So business users, they see, so you have 1 million records. On top of that 1 million records, if they need to see, so there's one specific requirement. If you see like how many candidates are coming to the retail store and not buying anything. So you have a swipe in and swipe out axis, or there are sensors that are installed. So there can be n number of use cases where you can do a lot of analysis.
I'm just going to interrupt you for a moment here. So you are saying that as a data engineer, you are the central person, or you're part of that central team, which makes sure that the data that is coming from different sources to an organization. For example, if I take Swiggy as an example, people can phone in and order directly on Swiggy customer care. They can use their app to order. They can go to their web portal to order. Maybe there is some offer on their Instagram, and they can use their Instagram page to order. So wherever the data is coming from, it goes to the the data engineering team, or at least their tools, which will ensure that the data coming from different sources are all in the right structured format, and so that the data consumers, which are basically data analysts or the data science team, can consume in a error-free, high quality, and consistent structured format, right? I think that's what you're trying to say.
That is correct, yeah. And basically, I believe the data science team basically does all the predictive analysis where, so it doesn't, maybe in future it is going to happen in real time, but basically we can understand the behavior of a person if we run all the history of, so let's take this Swiggy example. So a person placed 200 orders in a year. So we can clearly see what is his interest. And so right now we all get all the notifications exactly at the lunchtime. So they're going to push a notification. So hey, biryani is ready.
Okay.
Right. So depending on what choice I have, so the notifications vary from person to person. So there
Right.
can be a person who is always interested in sweets at 4 p.m. So in the background, so there are a lot of stuff happens. So they are going to analyze your history and get that information. And exactly one particular point of time, they are going to push notifications. For each individual, it's going to be a different.
Okay. All right. Good. Very good. One question to Gayatri, and so people ask, one of the questions that was asked in the chat window, I mean in YouTube chat as well, is what are the tools which normally a data engineer use when you start as a young data engineer? Because I understand there are several tools, but as a young data engineer, what are some of the tools that you end up using on a daily basis?
Okay. So to talk about tools, right? So before we have been using data warehousing as a tool. Like we had various tools like Teradata, and we had PostgreSQL and other things. But
Right.
Off late, right, the trend has been changing because those are not being capable of handling so much volume of data.
Right.
So now the trend is like where we have been getting into the cloud, where we land all the data in the cloud. We predominantly where we have been using AWS, Azure, and Google Cloud is where we have been using it. So instead of like ETL before, what we are going to approach of ELT. So first we are going to extract the data from various systems and we are going to land it on the cloud. We are going to land it on them, and then we are going to do the transformation of the data.
Okay, so now you are saying from ETL we have gone to ELT.
Yes, right. Yeah.
Before we transform, we land it into the cloud.
Yeah. So that by landing it, we'll have both structured, unstructured data. And for the transformation, right, for structured data, we have a set of tools. And for unstructured data, we have a different set of tools. And if it is a need of real time, we had a different set of tools. If it is like batch wise, there are different set of tools. The tools are like various now. Like to go for an example, like first we'll start with the batch. For a batch, right, where we have in AWS, we have tools like AWS Glue, we have Athena, Redshift. They are the tools which really works well when it is a structured data and it's a batch data. If it is a real-time data, I'm giving an example, everything of AWS itself. So if it is a real-time data, then we have streaming sort of tools where we have AWS Kinesis, where it can stream the data and where we can process the data. We can do the processing data, whether it's Spark streaming or we have a different analytics where we can do it, and where we can build the real-time dashboards, or we can make the real-time prediction as well. This can be used for machine learning model as well. And in case of unstructured data, like where the data is being like not a proper typical like a table-wise data, where it can be in any form. So for these sort of data, we generally go for NoSQL database. So where we can have documents over there, where we can have mission logs or all sort of information. We generally put it on the NoSQL database and we process based on the requirement. So finally, these are the set of tools, like based on the needs, how we are going to put it, we're going to cater to the need. And finally, for the consumer, right, they might be in different places, but they should have a common gateway through which they can access it. So we generally build an API gateway over there.
Okay.
So that through API gateway, they can access all this data through the API, one common gateway, and they can start consuming it.
API gateway is like a window to the to the data infrastructure, the data lake where the data is getting stored. So just to maybe just rephrasing what you just said, Gayatri, and correct me if I'm wrong. You're saying from different sources, when you're pulling the data, you put them into a data lake. You extract the data from different data sources. It could be a database, it could be unstructured data as well. And you put them into a data lake, which is like a large repository of structured as well as unstructured data. So that is where you are doing landing, right? Extract is when you're extracting, and landing it into the data lake is when you're landing the data, structured and semi-structured and unstructured data directly to the data lake. And then depending upon the type of data, whether it is structured, unstructured, then you do the transformation using different tools, right?
Yeah.
And then once it is transformed, then through API gateways, you give the access to that data in different data repository in the data lake to the consumers.
Right. Yes. You're right. Yeah.
So, okay, one follow-up question to Chandu then. Chandu, in terms of, because there are a couple of questions which have come regarding this only. In terms of specific tools which are famous right now, right? As a data engineer, as a young data engineer, what are the top 4 or 5 skills that a young data engineer should learn before expecting, to be able to convert the first interview as a data engineer? You are on mute, Chandu.
Right. So if you take so every day when you log in, so the first thing you are going to do is log into your cloud.
Okay.
So as Gayatri rightly said, so like 6 years ago when I entered data engineering, it was all on-prem clusters, right? So now, so I see no one using on-prem clusters.
On-premises, yeah.
It's gone. So those days are gone. So every day the question is, are you using AWS or GCP or Azure? So that's the only question. So all the projects are migrating from on-prem to cloud. So in cloud, so you log into Chrome or Edge, and you log into. So it's all different environment once you log into AWS. Like there are tens of services, hundreds of services available. So we use AWS EMR, Lambda, Glue, step functions, S3. So S3 you won't we won't even complete a day without accessing AWS. So that's the first thing. And the second thing is, in order to connect to all the servers, so we log into Putty. So as a backend engineer, it's not all the glittery screens that you see. It's all black and white screen.
Yeah.
So those are the lovely stuff that we see. We really enjoy working in that black screen. So you use
Well,
Putty.
you can change it to green and white also, right?
Sure. Yeah. And after that, we use in order to connect to any SQL server, Redshift, Oracle. So we use dbeaver. So in order to query. So once you do all the backend stuff, just to see how the data is there, to do sampling work and stuff. So we use dbeaver. And for each specific softwares, like so, every day we use WinSCP just to compare the minor differences that we miss, like maybe we missed a comma. So stuff like that. And another beautiful
So the
tool is
data
Notepad++.
cleaning, the data transformation, the data cleaning part.
Right. And another tool is I just mentioned Putty, WinSCP we use, dbeaver.
Putty and all are used to connect, basically, on the connection. Yeah. Gayatri, what would you say something?
Okay, so I think the tool specific when you're asking, right? Because now in the market there are many tools. So I think Chandu brought in the AWS tool. Even I mentioned about the AWS tool. If you see, there are competitive tools available in Azure as well as in GCP. So what I would like for a freshers, right? Stick with one tool, what you are going to learn, and understand it, like why it is getting used and how we are going to get used.
When you say one tool, meaning one cloud platform.
One cloud platform, like so that they understand what are the components of it, how it's getting associated with it. So once they know this, right, the same as the competitors are going to provide. So it's easy for you if you like, once you're going to comfortable with AWS, and if you get a project in Azure, it's going to be easy because you know the base. So just with a few days of learning, you'll be very much comfortable with Azure. If you see in case of AWS, the data storage is going to be an object storage S3. Even Azure has Azure storage. We can have blob storage and Azure Gen storage. It's the same equivalent tool. So there are many equivalent tools. So instead of getting diverted, I would suggest stick to one tool, be a perfect of it, and then you'll be able to upgrade easily to any tool.
Okay, very good. Basically, the message that you guys are saying is that, one cloud platform is very important. And cloud platform in the sense that since, because now the data comes and lands into one of the cloud platforms only. So the 3 major players, the AWS by Amazon and, Google Cloud Platform by Google and Microsoft Azure by Microsoft, become good in one of the platforms, because there are parallel services available in all the 3 platforms, right? And after that, you said that you need a way to connect and you need a way to clean the data. And, I understand for cleaning the data, SQL becomes a very, very important skill set for everybody to kind of exhibit, right? And now I think, a lot of companies are using Hive, which is Hive query language, which is, kind of a derivation of SQL. So if you're good in SQL, you can easily use Hive query language as well, is what I understand. Right, Gayatri and Chandu?
Right. Yes, yeah.
Yeah.
And then what I understand, and SQL becomes, or Hive query language becomes very important to extract the data as well as to clean the data. and or transform the data, that is. And then what about these tools, that we keep hearing about, Spark and Kafka, and what are your thoughts on those tools as well?
So everything is in AWS. So if you take AWS, so you have a big data cluster as EMR, AWS EMR. So once you log into that, so you can fire up your Spark, you can fire up your high queries, you can do streaming, anything is possible within that cluster. So just within 8 minutes.
Just to ask you one question that people ask is, so there is Spark SQL, then there is SQL as well, and then there is Hive as well, right? Yeah. And then there is Kafka for streaming. So can you just, in these most important tools, cloud data engineer, right? Can you in one line, explain the differences between these and their use cases?
Okay. So basically for all the things that Prateek mentioned, so SQL is the base. So you do Spark SQL, you do Hive, you do any SQL tools like MySQL Server, Oracle. So SQL is the base. So select start from table. That's where you start, and you do so you write thousands of lines of code in your first 2 years. So that's for sure. So normal SQL. So people started using SQL, and people thought, so okay, so why do I need to write hundreds of lines of Java code? So if I can do that with a one-liner in a code, so why should I do it? So then started Hive. Okay, so basically you write select queries and all the Hive commands, which are nothing but SQL kind of questions. Like it's 90% SQL only, so there will be minor tweaks according to the architecture. But if you take that, it's going to be you are going to fire up your simple SQL statements. But so the beauty is at the back end, the same SQL command is going to generate your Java code, right? So you are writing a simple select command in a SQL statement, and that is giving out a 1,000-line Java code, right? So it will be executed in the backend. So what happens in the backend, that doesn't matter to us, right? So what we are learning and what we are trying to write, so that matters to us. And so the enhancement to SQL is Hive. So I would say like that. And so Hive executes in Hadoop cluster, right? So it's a normal query. So if you want to get a better performance, so we go for Spark SQL, right? So the data is increasing, and you are always hitting the bottlenecks. So at that particular point of time, so you switch back to Spark, where all the in-memory computation happens, right? So it will be like 70 to 100 times faster when you try to do any analysis. You are trying to run a machine learning model. So if you take Spark ML, it's going to be like 100 times faster than what you are writing with a normal high queries.
Okay.
So yeah, so there's one step ahead. Each thing is going.
Right.
So SQL, then Hive, then Spark. Go ahead.
What I understand from you, Chandu, is that SQL becomes like a very, very important skill set that a person should exhibit, right?
True. Yeah.
And also some understanding of data warehouses, because if you understand data warehouses, you understand databases, and then you'll be able to appreciate the difference between data warehouses versus distributed platforms where Hadoop comes into the picture, right? And that's when serverless programming, and that's where Hive and all those things also come to the picture. But SQL and data warehousing becomes like very strong fundamental concept that one must exhibit. And then on top of it, then you're saying Apache Spark and Hive would come into the picture to kind of write the queries in a more performance oriented. One question for you, Gayatri. One of the questions that keep coming, okay, and in the chat window as well, somebody asked is, how much of coding is required? I mean, how much of software development level data structure algorithm kind of coding that is required as a data engineer?
Okay, fine. Okay. So one thing I want to talk about tools and then come up with this.
Sure.
So what you have been talking about, where Chandu has been talking about, where SQL is the base for it. And what I see trend is like along with SQL, even we need to know one of the programming languages. So like if you're going to use Spark, right, we need to know either Python, Java, or Scala. And I would suggest always go with the Python because it has got an enriched library, not just with Spark, even outside if you're going to like do any other programming. So it is good to have a Python knowledge. So always go with the SQL knowledge as well as the one scripting knowledge. So I would suggest Python. So if you're knowing this, right, not with Spark, you can use the same Python and you can go with any serverless component, Lambda function if you're going to write it. So all these things is going to be helpful over there.
Sure.
So, okay, let's go with it. So, and then coming back to your question, so can you repeat your question? Sorry, Prateek.
So my question was that how much of coding and it is the structural algorithm based coding that you require as a data engineer?
Okay.
A lot of people are very scared of coding per se, when they're.
Yeah. Okay. But being a data engineering, I would personally find we need to know coding. Coding is a must because there are various tools which can reduce the coding. So now it is now it's a way where we want to have industry also, right? They don't want to write all the codes. They want to use a tool which is going to give us less code or server like codeless, how much of it more possible with this job, just with the configuration, they want to run the codes. Like they want to, the tool is going to build the code. So that's how the industry have been heading towards it. So there are like for example, Spark, right? We have a basic Spark and people has to write a Python code and stuff. But there is a still on top of it, if you see AWS Glue has come up. If there is a simple transformation, the tool itself like an ATL tool where we can drag and drop, we can just create the connectors, what transformation is to happen, just with the look and feel. And backend, it's going to convert it to Spark code, the AWS Glue itself. So there are tools available in the market, but these tools are not 100% able to convert like all the codes. It's like simple codes to medium is what it's been able to do it. But the real business transformation, none of these tools are able to do it. And people has to code it. And for that, the coding, they need to know the programming language or the SQL. And being a fresher, I would generally suggest them learn both of them, be a perfect of it. That will be helpful in the long run for them.
So basically, Gayatri, you're saying that knowing SQL as a language is very important, and supporting SQL with one of the scripting languages, whether it is Python or Scala or even Java, that is important. But your recommendation is that one should know Python coding essentials as well. That is very, very important. A lot of things can be done using the tools, the graphical tools which have come, including AWS Glue and so many of them. But you still have to modify the code, review the code as and when required. Very good. One interesting question to Chandu, and then probably the same question to Gayatri as well. So Chandu, I mean, people want to understand that why do you guys feel that data engineering as a career will remain very, very active and very relevant in the coming decade?
Okay, interesting question. So going forward, we are not going to go back to Stone Age. So always, so it's 2 GB mobiles, 4 GB mobile, 16 GB. Now, so they are trying to create 256 GB. So a lot of stuff is happening. So it was like 5 to 6 years ago. If you take any application, Android application, it used to be around probably 16 MB, 20 MB, not more than that. So now if you take an Instagram size, so after installing, it's going to collect a lot of information. Like if you go to your applications and see what is the size of each application, it's around 300, 400 MB. So that means what all the activity that you're trying to do, so it is trying to get a lot of advertisements on top of it, right? So nowadays, data is real currency. So if you ask me, data is your real currency. So all the MNCs and all the apps so they collect all the information. If I try to talk something, so they're trying to capture that and giving advertisements on top of it. So if I just Google something on my mobile, so the same thing, a similar thing is reflecting a advertisement in my the blogs that I'm trying to search, right? So see what all things happening in the background. So going forward, so the data is going to increase so exponentially, even we won't be able to handle all the data. So as Gayatri mentioning, so we are just trying to capture 5 to 10% of the data. So the development at which the apps are collecting this data, so how much the data that is growing on is, so in the current scenario, the data engineers that are equipped with, so we are not sufficient. We need a lot of manpower, and so many people are scared with ChatGPT. So we'll get back to that, but nothing is going to replace humans. Nothing is going to replace data engineers, because we'll always be there as long as you are holding a mobile, as long as internet is working, and as long as your laptops are there. So data engineering will always be there. No doubt with that. So if there is some apocalypse happens, then so we don't need data engineering till then. So we'll always be there.
All right, very good, strong point. As long as there is data, there are apps, and there is internet, and there are phones, there will be requirement for data engineers. How about you, Gayatri? What are your thoughts on this same question?
Okay, so I think Chandu brought up most of the point. So the other aspect, what I need to bring up is, like, as I was mentioning, there are tools, because I have worked in various organizations and we might be landing the data from different system. It's like same, we can land it. And then we need to do a transformation. And based on the organization domain, we are going to do a transformation. So it was not the same transformation. What I do it here in the X company, the same would work for a Y company, because their business is different and the way of data is different and it's different. So what happens, it's become someone really a human who needs to understand the business, like what is the domain and what transformation is really needed for that data is what the human has to decide. And there are no common tool is also which has not been available. So if you see for landing the data from different system into cloud, because it's a simple, there is nothing needed for it. It's like, so there are various tools available and that can be automated. When we really have to build the transformation for it, no tool has come up in the market which can do the transformation 100%. They might be just 5 to 10% is what I have seen it, but not the real 100%. Someone has to, so there should be a data engineer who has to do that manually. And at least like next few years, I don't see there is a tool which is going to come up like that. And only after that, if there is a tool such thing, then ChatGPT might be on top of it, which can simplify the work. But at least in near future, I don't see that is going to happen. So data engineers are needed.
So both of you brought this interesting thing about ChatGPT, right? So one of the questions that people keep asking me is, how does ChatGPT impact the data engineering career? So what are your thoughts, Gayatri? And then I'm going to go to Chandu as well on the same question.
Okay. But from my perspective, right, ChatGPT is like completely different compared to what the data engineers are doing. ChatGTP is an AI model, is an AI model where it's really like going to replace a chatbot. So chatbot can be something like if you're going to log into any website or something, it's going to be an automated message now where if you're typing some question automatically, like how Alexa gives it and stuff, right? So ChatGTP is something like an advanced version of it. And I think in the conversational side and the AI perspective, it is good, like because they have many trained models on the machine learning models. But that open AI, like which is a ChatGTP, doesn't have much on the data engineering space currently. Might be in future they might enhance it, but currently there is nothing on the data engineering which can replace it. And I find AI has not gone to that level which can replace a complete human data engineering at this stage.
Okay. How about you, Chandu? Same question.
Yeah. So any data engineer, so you won't pass a day without using Google, right? So you need some syntax. So everyone, so it is not a hard and fast rule. You need to remember all the 100% syntax free code. So you get some doubt, so you are going to Google it, right? So we used to go to Stack Overflow for all the questions that we have. So that's like a standard dictionary for data engineers. So now ChatGPT is going to be replacing the Stack Overflow. It's a controversy, but so you ask a question to ChatGPT. So I need to build a Spark code. I need to read data from Oracle. I need to store it in AWS. And then, so I started using ChatGPT and it's wow. But it's not going to completely replace. So what we are trying to do now, so rather than going to Stack Overflow, we are going to ChatGPT and ask a lot of questions, but it needs a lot of customization that need to be done. So
I mean,
yeah,
actually, that's a very good point. That's a very good point that you brought. In fact, whenever people ask me, will ChatGPT, I mean, I'm talking from a perspective of a data analyst or a data scientist or a data engineer, right? We used to go to Stack Overflow, as you correctly said, for some syntax references, or we are getting some errors, and just to cross check if somebody else had faced the same error and what is the solution that they have recommended. So now instead of going to Stack Overflow, people have started going to ChatGPT. Right? I mean, it has to become more convenient. I mean, Stack Overflow is very convenient. Just Google and you get the answer. ChatGPT, half the time the system is down, but I'm sure that will become better. But yeah, I mean, so if at all ChatGPT is going to replace Stack Overflow as as a tool to kind of tell us whether our syntaxes are correct or to tell us where the error is in the code. So for referencing, whenever we used to go to Stack Overflow, I mean, we would probably now go to ChatGPT. Very good answer there. Couple of basic questions as well I wanted to ask you guys. I mean, you guys have, you guys are recruiting as well. You guys are part of interview panels as well, and you work with a lot of young data engineers as well. So what are your perspective? I mean, Chandu, starting with you, what is the kind of average salary that you see for a fresh data engineer hired in a company? Some ballpark.
So if you take Yeah, if you take your standard servicing companies like so TCS, Cognizant, Accenture, a lot of service-based top companies which has more than 10,000 employees, so they are not going to hire fresher graduate who are from normal engineering, private engineering colleges. They are going to hire everyone so at a salary of 3.5 lakhs to 4.5, not more than that. So it's been the standard from last couple of years, so it could have been restructured, but so that is how it is. But if you are going to join a startup company or a medium-sized company or a small-scale company, so there is no limit to how much a person can get. So depending on the skills and the kind of coding that you do, the data structures that you know, algorithms. So you can start with 10 LPA and so quickly scale up to 10, 20, 15. I mean, so there is no limit, upper limit, but so everyone starts with 3.5, 4.5 LPA
This service
and
company.
quickly scale up. Yeah. So depending on the service company or a startup.
What are your experience, Gayatri?
Okay. So where Chandu brought up, right, for a fresher being like in any service, right, they'll not be hiring specifically for a data engineer. When I was a fresher, right, I never knew, like they hired me, they gave me a bunch of training. And when they put me, I got into a data engineering space I had got into, but the salary was same, whether I'm in data engineering or the application engineer is the same. So that's how it's going to be in the start of career. If they're going to be in the pool and going to start, it's going to be the same what you're telling. Around 4 lakhs is the package what they would be giving. And there are some captive-based companies or the product-based companies where they'll be giving a higher salary for the freshers, even if they're getting in the pool, right? So they might be starting with 7 lakhs, 8 lakh packages over there. But after some years, so they might be starting up in different, what I see is like they might be in consultancy companies, some might be in the captive-based company. But after 2 or 3 years, right, they would be experienced, whether in this company and this guy. What it gains more is like in the 2 or 3 experience, what is the knowledge they're going to gain it, the domain experience, the tool experience, and how good are they going to optimize the code, what they're going to do it, right? That what it matters a lot. What I see is in these 2 or 3 years. And this both company once after 2 or 3 years, if they have to jump it, right, the both are competitive enough to get a same salary. So definitely they would be getting like 12, 13 plus is what it matters.
First, so the message that I think Gayatri, you're giving is you may start low or you may start maybe a little higher, but the first couple of years are the learning years. And if you're able to build that capability in the first couple of years, it will add a lot of value to your future mid-career.
Right, yes.
So instead of rather focusing on the starting salary, the focus should be on the kind of work profile that you will get.
Right, yes, yeah, definitely.
So that brings me to one more question to both of you, maybe starting with Chandu, is, I mean, because we got just a couple of minutes remaining, what would be the steps that you would recommend for a young, let's say there are a lot of people who are doing our courses, in Ivy data engineering courses who are interested, who have had data science kind of a background or data analysis kind of a background, but now they want to upskill, or maybe they were software engineers in some other company or they were into IT and they want to upskill into data engineering. So what kind of steps would you recommend to such a person, Chandu, and then to Gayatri?
Okay, so first, strengthen your skills, right? So first and foremost, so learn a Python. So I recommend Python. It's easy compared to all other programmings. So learn Python, learn SQL. So get better at it, right? So try to do lot of scenarios, lot of case studies. So when you learn something, when you sit and listen to something, so you are actually not learning something. You just know it. Okay, so when you start doing something, so you take a 10 GB data set or 2 GB data set. So try to do a lot of queries on it. So try to read it, parse it, do some data cleansing. So when you start doing and when you get into the data, so in my initial years, I used to get all the dreams into like so rows and columns only. So in my first 1 year, it's really nightmare. I mean, so I start thinking about it and it's so good. I mean, so daytimes it's so good, but night times I won't get any sleep because I keep thinking about that particular row and column. So what is that issue? How do I solve it? So for a year, I mean, then I started getting used to it. So that's a different kind of thing. So get better at what you're doing. So learn a programming language, learn SQL, and get better at one of the AWS or GCP, any cloud, because nowadays no one is using any of the on-premises things. So you need to know. So as Gayatri rightly mentioned, so if you know AWS, so learning Azure is like a 1 week kind of thing. So the base layer is going to be the same in all the clouds because they are not going to invent something that is practically new. So they are going to have a big data cluster. They are going to have a storage, and all the services are going to remain like 90% same. So there will be a flavor variance of 10%. So get better at these things, and
Very
so
good.
there is
How about
lot of scope. Yeah, go ahead, Gayatri.
Okay, yeah. Yeah, thanks, Chandu. Yeah. So I think to add some more point to Chandu, right? So we might be now where the trend is to get into the cloud, like AWS, Azure, and GCP. But if you see, still the base for all this technology, what we have it in AWS, there'll be something on the open source. Like if we have like AWS EMR, that is a Hadoop environment. Still, they take a open source of Hadoop and they made their customization. So it's going to be enterprise wide, and they've implemented so that like enterprise customers, there's no need to do all this configuration. They can start using it. Like any tool like Athena, what they're going to use, Glue, if they see its backend is a Spark. So everything, if you see, there is something backend at open source, which they've been using it. So to start, if you want to jump your career into a data engineering, right? So like read Hadoop, like that might be the first step for you. Just understand the concept of it. What is HDFS, like what is Spark, Hive. So if you know this concept, right, the same concept could be expanded further if you get into the cloud, if you get into the AWS. So start with like the tools would be like start with Hadoop and then go to the cloud and learn how exactly the same technology, how it's getting implemented through various other tools. So now with the Google, right, even AWS gives a suggestion what is the architecture they're going to be. Like for an example, if you see for data engineering, it will give multiple architecture, the tools, what it has to use it. Like what is the script to load it? Like what should be the script? Like what are they going to use it? Is it going to be Lambda or is it going to be Glue? Or what they are going to use it? Is it through Spark streaming, EMR? They have different architecture. So then you'll be able to understand what tools does it going to, then you can learn further of it. So the base is, I would suggest go to Hadoop, get the base of it, and then go to the AWS.
Okay, AWS or one of the cloud services.
One of the cloud provider, any cloud provider, yeah.
So thanks a lot. Thanks a lot, everybody. Thanks a lot for answering this question and all the questions, guys. And we have run out of time, but thank you, everybody who has joined today, and thank you for asking all the questions. I know a couple of questions we couldn't take into the discussion because of the time paucity, but I must thank Chandu and Gayatri for joining us today and giving their insights and sharing their experiences in such a candid, informal fashion. Thanks a lot. Just to conclude, right, taking some of the pointers from whatever Chandu and Gayatri said today, starting with what is the scope of data engineering career, right, in the coming years. As Chandu very rightly said, that as long as there is internet, as long as there are people who are using applications, software applications, and so forth, there will always be data, and there will always be a need for a data analyst. And as Gayatri said, that ChatGPT is not a replacement for a data engineer, but and as both of you guys said, that ChatGPT is more like being able to answer some of the questions, some of the code errors, verify some of the code errors that we are getting. So it's more of a replacement for Stack Overflow than replacing a data engineer. So ChatGPT is not really a scare to a data engineers. And also, both of you guys mentioned collectively couple of skills that a fresh data engineer must know, right? I mean, as Gayatri was just talking about, that a good a fresh data engineer should adopt one cloud technology, whether it is AWS by Amazon, whether it is Google Cloud Platform or a Microsoft Azure. Second, one should become very good in Hadoop distributed file system environment. So Hadoop is very important. Both of you guys mentioned that learning SQL becomes a very, very important skill, because SQL is the base for Hive. SQL is the base for Apache SQL as well, which are some of the tools which are used very prominently in ELT, extract, landing, and transformation environment. Third thing you guys mentioned is that you must complement your skill with one scripting language, one programming language. Make it Python. Both of you recommended. It could be as well. It could be Java as well. But Python, anybody can learn. It's very easy to learn. And one of the other questions, where you said that yes, coding is required. Coding is one of the things that data engineers should know. But there are a lot of tools which have come in the recent past which kind of help you reduce the effort to code, and your experience, your role then becomes as a data engineer to read those code and being able to modify those codes. And at the end, I would just want to add one small snippet to the entire discussion and to the context of the discussion today, which is, I was watching one of the cricket matches in the last T20 World Cup, India-Pakistan cricket matches. There were more than 500,000 people, there were more than, if I remember it correctly, there were more than 50 million people watching that on Hotstar app. All these people who are watching this on a streaming app, right? Now imagine the kind of data engineers that they need, and they imagine the kind of data engineering technologies that they need to in order to scale up the app so that there is no buffering. And I was surprised there was no buffering. The app did not crash. And then I went to Google, and then I saw one of the speeches by one of the CTOs of Hotstar. He explained how the app was scaled up and managed by the entire data engineering team. So remember, guys, the entire paradigm is getting shifted towards using these applications which are data heavy, right? And that's where the opportunity lies, guys. Thanks a lot, Gayatri. Thanks a lot, Chandu, for joining us today. And thank you, everybody, for asking all the relevant questions. And, this recording will be uploaded onto IvyProSchool's YouTube channel. And all the skills that Gayatri and Chandu spoke about today are very nicely covered in our Cloud Data Engineering certificate program, which comes under our NASSCOM and Government of India certification program. And do check that out on our on IvyProSchool's website. And feel free to drop in your questions in the comment once the video is recorded and loaded onto YouTube, and we'll be more than happy to answer those questions. Thank you, Gayatri. Thank you, Chandu, for joining in today.
Thank you.
Welcome, Prateek. Yeah, it was a pleasure talking to you.